Welcome to the last video in section 4, Graphing Relations. Now in this video we're going to have one last look at graphs. It is a topic that is so important to master, from reading graphs, creating graphs, to manipulating graphs. These are all important skills for any mathematician to have, as they are used frequently to provide a visual representation of a relation and can also provide a lot of information. So let's have a look. The graph here relates the cost of renting a party room to the number of guests attending. So before we go and answer any questions, let's examine this graph further. I notice on the bottom I have the number of guests. On the vertical axis I have the total price, and all of the points lie in a straight line, meaning it's a linear relation. Now let's consider the scale. On the bottom, not every block is marked. So what is this first block here worth? Well, if the second block is 2, the first one must be 1. So increases by ones. 1, then we have 2, then this one must be 3, then we have 4, and then 5, and so on. Now, it was discussed in a previous video how sometimes we don't put in every single number because it would be too cluttered. Now, what about the vertical axes? What is this block here worth? Well, it's not 1 because the next block is 8, so it can't go from 1 to 8. It must be half that, which is 4. So that's 4, then we have 8, this one must be 12, and then we have 16, and so on. So it's okay to have the scale on the vertical axis be different than the scale on the horizontal axis, like we have here. So now let's see what question A asks. It says, how much would it cost for 24 people to attend? So if I look at the horizontal axis on the bottom for the number of guests, I see 24 right here. Now when I look at the points on the graph, I see that they don't quite reach 24. So let's extend the graph. If I look at every 2 points, I notice that they all have the pattern of going over 1 block to the right and 1 block up. So if I continue that pattern, I get these 2 dots here. So that means for 24 people to attend, I can go straight up to the point and then straight over to the total price. Now we already determined that the scale was 4, so that means that that corresponds to $156. Now part B says if the cost of the party was $120, how many people attended? So this time I'm going to look for 120 on the vertical axis, which is right here. So if I go straight over to a point on the graph and then straight down, I see that that corresponds to 15 people. Now part C of this question wants us to write a relation between the cost of the party, using the variable C, and the number of guests attending with the variable G. So let's do that here. Now to write the relation, we can write all the values in the graph into a table, as we are used to writing relations from a table of values. But let's just observe the pattern in the graph here and write the relation using the graph. Now if I consider the very first 2 points, if I were to go over 1 block to the right, meaning for every guest we have, the total price is also going to go up 1 block, which really corresponds to $4. So we can start off by writing our equation as C equals 4 times G. Now let's plug in a value for G. So if I say that there is 1 guest, 4 times 1 equals 4. Now looking at my graph, I see that 1 actually corresponds to $64, not $4. So how can I adjust my equation to get 64 as opposed to 4? Well, I can just simply add 60. So that means our equation is C equals 4G plus 60. Now it's always good practice to replace G with another value to see if it corresponds to the value in the graph. So for example, if you replace G with 2, looking at my graph, I should get a value of 68. So you should try that. Now let's practice writing relation from a graph again. In this example, we have parking garage fees. So on the bottom is the number of cars, and on the side is the total amount of fees collected. So once again, I'm going to pay attention to the scale here. On the bottom, I notice that the scale is 1. Every block is worth 1. What about the vertical axes? So if it starts at 0, we have 1 block, and then the next block after that is 10. So that means the one in between must be 5. So each block on the vertical axis is worth $5. So now let's consider the first 2 points again. If I go over to the right one, meaning 1 car, the total amount of fees increases by $5. So I can start off with the relation and say that the fee, F for fee, equals 5 times C. Now let's replace C with 1. 5 times 1 is 5. Now what does the graph say my equation should equal? When the number of cars is 1, the fee should be $25. So I can go ahead and add 20 onto the equation, so I would get a value of 25. So F equals 5C plus 20 becomes our equation. So that's how you can write a relation if you don't have a table of values and you're just given the graph. You just need to consider what each block increases by on the horizontal and vertical axes. Now in this last example, we're going to match each relation to its graph. So let's start with the relation 10 minus x and replace x with a value. Let's replace x with 0. So if I do 10 minus 0, I get 10. Now look at each of these 4 graphs. Which graph has a y value of 10 when the x value is 0? That's in 2 graphs. The first graph and the last graph. Each one of those has a y value of 10 when x is 0. So remember that x is 0 is down in the corner. So now it's between these 2 graphs. So in order to determine which graph it is, we need to replace x with another value. So let's replace x with 1. 10 minus 1 is 9. Now between these 2 graphs, I'm looking to see when the x value is 1, which one has a y value of 9. And you'll see that that is the graph here on the right. When x is 1, y is 9. So let's draw a line to match that relation with this graph. Now for y equals 2x plus 1, let's do a similar process whereby we replace our x value with a number. So say x is 1. 2 times 1 is 2, plus 1 gives me 3. So which graph has a y value of 3 when x is 1? Look at the 3 remaining choices. You'll see that that is this graph right here. So we can draw a line connecting that graph to that relation. Now for 10 minus 2x, let's go ahead and replace x with 1. So 2 times 1 is 2. 10 minus 2 gives me 8. So I'm looking for a graph that has a y value of 8 when x is 1. So between the 2 choices, you'll notice that that corresponds to this graph right here. So I'll draw a line. And lastly, y equals 2x minus 1 must match this graph here. But let's just have a look to confirm. Now, you might have noticed that in each one of these, the value that's before the x, in this case we have a 2, corresponds to how much the y values increase by. So if I look at the graph, if I go over 1 to the right, the graph goes up 2. So that does confirm that that graph matches that relation. So that concludes the section. Be sure to complete all the activities before moving on.